This is mathematics paper 2 2017 GCE. So I'm saying using a scale of 1 centimeter to represent 1 unit on each axis, draw x and y axes for, we've been given the range. Okay, so the good part with transformation, it's very easy. Okay, just check the way we're going to handle it. So first of all, I'm going to bring out the ranges, because we are using 1 centimeter to represent 1 unit. So half of that bigger box on your graph paper, that is the 1 centimeter. So meaning that bigger box will be a 2 in short. Alright, so let us put in our value. So we have the Cartesian there. This is the origin. So we're putting numbers. So half of this box, if I'm counting here, this will be 1, this will be -2, this will be -3, this will be -4, just like that. Okay, so half of that box, you'll be counting it as 1. Okay, it means a full bigger box will be counted as a 2. So I'm going to use a 2 for me. Okay, so -2, -4, -6. Same applies in the y-axis. Okay, even on the right of the x-axis. Now we can plot our values. So question A says quadrilateral ABCD has vertices, that is, these are the vertices, okay, the points. And quadrilateral A1, B1, C1 and D1 has also some vertices that we've been given. Alright, so A Roman numeral 1 says draw and label quadrilaterals ABCD and A1, B1, C1, D1. 2 marks. So let us plot. So we have the first quadrilateral that we are plotting. So the point A is 1, 2. So 1, 2, the way it is going to be here. So 1 in the x-axis, 1 is here, 2. So you move, this is a 2 here. So this is where the point will be. So our point will be right here. This is A. Then 2, 1. Okay, 2, 1, that is our B. So 2, 1, 1 is here. Half of this box, the bigger one. So a point is here. Then C is 3, 2. So 3, 2, 3 is here in the X, 2 is right here. Okay. So this is where our point is. This is our C. Then our D, 2, 3. So 2 is right here, 3 is right here. Okay. So that is where the D is. Then we draw this shape. Okay. So we connect the lines or the points. Okay. Forming that square there. Let us go to another quadrilateral, which is the A1. So the A1 is 3, 2. So this is the 3 in the x-axis, 2. So this point will just be here where the C is. Okay, this is where the point is. That is our A1. Then B1 is 6, 1. Okay, so 6 is right here, 1 is right here. Okay, that is our C1, our B1, sorry. Then our C1 is 9, 2. So 9 is here in between 8 and 10. 9, okay, 2. So the 2 is right there. Okay, this is our C1. Then D1 is 6, 3. So 6, 3 is right here on this point. Okay, let us connect these points as well, forming that shape. So we are done. We have gotten 2 marks there. Let us find Roman numeral 2. Describe fully a single transformation which maps quadrilateral ABCD onto quadrilateral A1, B1, C1, and D1. So they are asking us to describe this transformation that has shifted these points to this new shape here. If you remember what we talked about, the first 3, those are isomers, okay? Meaning they maintain the shape, the size, and the actual shape, okay, of your object. They do not deform it. When you look at this image here, the D1, the A1, you look at this shape and this, you see that they are totally different. Okay, the shape looks as if it has been deformed, meaning it can't be the first 3. Again, if we go back to enlargement. Enlargement, we have said, it just increases the size of your object. All right, so it means it maintains the same exact shape, but it just increases the size of your image. There are similarities. Look at this. Can this be enlargement? No. The shape has changed. It looks different. Okay, yes, it is big, but it looks different. Okay, so it means it can either be shear or it can be stretch. Now, let us first of all define what shear is and what stretch is before we pick which one is the correct one. So shear maintains a fixed line, and that line is called invariant line. Okay, it maintains a fixed line and moves other points parallel to the fixed line by a distance which is proportional to their perpendicular distance from the straight line. Okay, then what is a stretch? A stretch is an enlargement in one direction. In a stretch, the movement of points is perpendicular to the invariant line. Okay? When you just look at this, have you seen the increment? The increment is happening just on one side of this shape. Okay? So meaning this is not a shear. Okay? This is a stretch. Because the increment, the enlargement is just happening on one side. And of course, other points there, they are moving perpendicular to the invariant line. Now, what is this invariant line? Under stretch, there are only two invariant lines. It's either it's under the y-axis or the x-axis. So if you look at the way it is being stretched, okay, it is being pushed, stretched towards our right-hand side. Okay, so meaning the invariant line should be perpendicular to this. So perpendicular to this is what? Perpendicular to a line like this, it should be the y-axis. So we've identified. So now, having known that it's not a shear, it's a stretch, now it is possible for us to describe fully. Okay? Because for us to describe fully, there are these three things that we need to know. For us to describe a stretch, one, we need to state its name. Two, we need to state the stretch factor. Three, we need to give an invariant line. So in this case, we have discussed that this is being stretched towards our right-hand side, meaning the invariant line is the y-axis. So we have identified one point there. So invariant line, y-axis. Number two, having known the invariant line, now we need to find or calculate the stretch factor. Okay, so the stretch factor is represented by K. Now, in this case, what you're going to do for you to find the stretch factor, you're going to use the distance from your invariant line. In this case, it is our y-axis. So from y-axis to one of the points on the image. Okay, so let us say we pick point A1 here. Okay, A1 is the image. So we're going to move steps. Remember, we are moving in a 1 centimeter box, we are counting as 1. So this is 1, 2, then 3. So up to A1, we are counting that one as a 3. Okay, then we are going to pick a corresponding point to A1. So corresponding, meaning the object of A1 is what? A. So from the line again to A, that is 1. So we're going to divide there, okay? So K is equal to A1L. A1 represents the image, then L represents the line. So from the y-axis to A1, what is the distance? We said it's a 3 when you count there. Then from the line to A, the distance there is 1. So we'll divide the 3 over 1. So you are dividing the distance from the invariant line to the image over the distance from the invariant line to the object. Our stretch factor will be a 3. Now, having known these things, now we can describe. This is how you describe. So you're supposed to show this because it's a 3-mark question. So you say it's a stretch with stretch factor of 3 and invariant line in the y-axis. When you write like this, it means you have described fully. You get your 3 marks. Let us proceed to another question. Question B says, the matrix 1, 0, 3, 1 maps quadrilateral ABCD onto quadrilateral A2, B2, C2, D2. B Roman numeral 1 says, find the coordinates of quadrilateral A2, B2, C2, and D2. We need to find the coordinates. So when you're given a matrix, okay, when you're given a matrix, this is a transformation matrix, meaning for us to find the coordinates, we are going to use this matrix. No wonder in the prerequisite, we said you're supposed to know matrices. Check how we're going to use the concept of matrices now. So we bring out this transformation matrix. We are going to multiply it now with the coordinates of our object. So our object is ABCD, which is mapping these points here. Okay, so this is how you write. Now let me just bring out these. Okay, so the coordinates for our object are these you're seeing here. So where am I getting these numbers here? So this is what happens when you look at this matrix, the second matrix there. Have you seen the numbers that are on top there? Check the x values. So when you check the x value for A here is 1, this is the 1 you're seeing. The x value for B is a 2, this is a 2 you're seeing. The x value for C is a 3, and then for D is a 2. So you write the x values in the first row of your second matrix. Then the y values in the second row. So first row carries the x values. Second row carries the y values. Okay, so now having known where the second matrix has come from, now we can multiply. Okay, we are multiplying row by column. So we have 4 columns. Okay, now look at this. Okay, so when you see this, the first row, it has 1 and a 0. I'm multiplying it to these columns. So where you're seeing colors there, those are different columns for the second matrix. Okay, so 1 times 1 here in the first column, then plus 0 times a 2, this 2 here. Okay, then leave space. The same row, 1 times the 2, okay, plus 0 times 1. Then 1 times 3 plus 0 times 2. Space 1 times 2 plus 0 times 3. This is what is happening on top. You do the same even in the second row. Okay, so you drop down. You again use now a different row. 3 times 1. But the columns will still be the same because we are still using the same second matrix. Okay, I think you have remembered the concept of matrices. Okay, now when you multiply there and add, you're going to get your final answer as this. Okay, so here when you look at on top here, the second part will always be a 0 because we are multiplying with a 0. So we'll just have a 1, 2, 3, 2. Okay, then here 3 times 1, it's a 5. It's a 3. 1 times 2, it's a 2. Then when you add 3 plus 2, that's where you're getting a 5. Then same applies here. You do the same even there. Now we have found our coordinates. So we can label them now. The first coordinates, these are corresponding like this. The first coordinate, that is for A2. Second, B2. Third, C2. Then lastly, D2. Second question says, draw and label quadrilateral A2, B2, C2, and D2. Let us label it. Let us draw and label. So we'll come here. The first one is 1, 5. So 1 in the x-axis, 5 is right here. This is our A2. Then second one, the B2 is 2, 7. Okay, remember the values on top here, they're representing x values. The values down here are representing y values. Okay, so 2, 7. So the 2, comma the 7 will be here. This is B2, okay? Then C2 is 3, comma 11. So the 3 is right here, following this line up to somewhere above 10. That's up to here. That is the C2, okay? Then D2, that is 2, comma 9. So the 2, comma 9, that is there. Okay, that is our D2. Now we can connect the points, okay, forming that particular shape. Okay, we've gotten 1 mark there. We proceed to question C. Quadrilateral A3, B3, C3, D3 has vertices. So we've been given the vertices in this case. Describe fully the transformation which maps quadrilateral ABCD onto quadrilateral A3, B3, C3, D3. So since we already have the quadrilateral ABCD, this original object here, let us plot these coordinates and then see first of all, because we can't describe without the actual shape. So let us plot. A3, we have negative 2, comma 4. So negative 2, comma 4, negative 2, comma 4 is right here. Okay, this is A3. Then B3 is negative 4, comma negative 2. Negative 4, comma negative 2 is right here. That is B3. C3, negative 6, comma negative 4. Negative 6, comma negative 4 right here. Okay, then D3, negative 4, comma negative 6, which is right here. Okay, let us connect these points. All right. Now, look at this. Before we even begin to describe, look at the shape. All right. When you look at the AD, AB, CD, and when you look at this shape here, the shape looks exactly the same. This is a square, even this one is a square. But now, the shape has not been deformed. But what has happened? It has just increased in terms of shape. What type of transformation is that one? You are correct. What we discussed, we said, that is enlargement. So enlargement is the only one that just changes the size of your object, but maintains the same exact shape. So now, for us to be able to describe fully, there are again 3 things that we need to state. The first one, you need to state the name of the transformation. 2, you need to give the scale factor. So for enlargement, we call it as a scale factor and not a stretch factor. Then the last one, you need to state the center of enlargement. So the first step we're going to take will be to find first of all the center of enlargement. So when you know that this is enlargement, first of all find the center. So how do you find the center? You're going to pick corresponding values, corresponding points. So let us say we pick point A3 and point A. Those are corresponding, okay? So A and A3, they are corresponding. You're going to use a ruler and draw a dotted line connecting these 2 points. Make sure you extend these lines, okay? Like this. Then pick another point and its corresponding point. So let's say we pick B3 and the B here. Again, connect them with a dotted line using a ruler. Okay, you'll find that those points, those lines that you've drawn, they are going to intersect at a particular point. Like in this case, they are meeting right here. So at this point where they're intersecting, that is where your center of enlargement is. Okay, so our center of enlargement, they are meeting right here at the center. Okay, at the origin, the 0 at the 0, 0. That is where our lines are intersecting. Okay, so now since having known the center of enlargement, now we can find the scale factor. Okay, so the scale factor in this case will be the distance from the center to the image, okay, divided by the distance from the center to your object. So look at this. The distance from the center to my image, let's say the A3, that is 1, that is 2, then 4. Okay, so from the center to this point, that is 4. Then from the center to the object, which is A, that is 2. Okay, because this is 1, then 2. Okay, so now we can write down those values. So k is equal to 4 divided by 2. Okay, when you divide, k will just be 2. Now, having the scale factor, knowing the transformation, knowing the center of enlargement, we can describe. So we'll say it's an enlargement of scale factor of 2 with center 0, 0. You have described fully and you get your 3 marks. So thank you very much guys for watching up to the end of this video. If you liked and enjoyed this video, please don't forget to subscribe. See you in the next video.